All right, let's simplify each expression. We're just distributing here. So 7 times v would be 7v, then 7 times 3 would be 21. You can't combine 7v plus 21. They're unlike terms. So 3 times u is 3u, and 3 times negative 8 is negative 24. Here we've got negative 5 times 6 is negative 30, and negative 5 times negative 3t would become positive 15t. Now, again, if our goal is to eventually get these in the standard form, you usually put the exponents before the regular numbers there. So we would say 15t plus negative 30 or minus 30. So if you can get into that habit now, save yourself having to adjust later. Find the area of the garden. All measurements are in feet. Now, when you're finding the area of a rectangle, you just do length times width. So we have to do 2x times x minus 5. Now we've actually done problems just like this. This is just mushing two problems into one. So when we did properties of exponents, we did 2x times x. So you just do the numbers in front first. 2 times 1 is 2. And then when you multiply x times x, when you multiply the same base, you add the exponent. So that would be x squared. And then when we do 2x times negative 5, 2 times negative 5 is negative 10. You just have the x there, so negative 10x. So you're going to be doing x times x all the time, so just remember that's x squared. You don't have to remember the property of adding the exponents for just that because you'll do it so many times. X times x is x squared. So here 3x times x is 3x squared, and 3x times 4 would just be regular 12x. Over here, x times 2x is 2x squared, and x times negative 3 is negative 3x. And again, these are in standard form, you'll notice. The exponents go down. This is x to the second, then x to the first, and if there was like a 5 there, that would be x to the 0 power, so that would go at the end. All right, so again, here we go. We're just doing the same thing. Now when you multiply and the bases are the same, you add the exponents. So here, when I'm doing the x squared times x squared, we add the exponents, which would give us x to the 4th. So the numbers in front, 3 times 8, 24, x to the 4th. Now we're going to do this 3x squared times negative 5x. So 3 times negative 5 is negative 15. X to the second times x to the first, add the exponents, x to the third. And the last one, 3 times 2 is 6, and then we just have the x squared. We're not getting any more x's. So this is in standard form. Your exponents go down. It goes to the 4th, to the 3rd, to the 2nd. If there was x to the first, it would go after that. If there was a regular number, it would go after all of that. So I want you to try these two. Pause it here, try them out, check back in. Oh, let's see if we have the same thing. X times x squared is x to the 3rd. X times 2x is 2x squared, and x times 4 is 4x. Over here, 2 times 2 is 4. A to the 2nd times a to the 3rd is a to the 5th. 2 times negative 3 is negative 6. A squared times a squared would be a to the 4th. 2 times 3 is 6. We're not getting any more a's, so it would be a squared. All right, and this is it. This is what we're going to wrap up with. Write this as a product of two factors. So this is like the opposite of what we were just doing. So we kind of did this back in the day when we were doing like a light version of factoring. So we're going to look for the greatest thing that they all have in common. So let's just look at the numbers. 6, 3, and 9. What goes into all three of those numbers? 3. Now, do they all have an x? Yeah, they all have at least x to the first power. So we're going to kick out a 3x. And then we're going to kind of go backwards from here. So this is like the opposite of distributing. So 3 times something gives me 6. That's 3 times 2. We have x to the first. I need x to the third. So we need 2 more x's. So 2x squared. So 3x times 2x squared gives us that 6x to the third. The next one, we're looking to get from 3x to 3x squared. So 3 times 1 is 3. We don't need to write the 1 here because we have to do x times another x. That would give us the x squared. So 3x times x give us that plus 3x squared. And the last one, we're looking to get to 9x from 3x. So 3 times 3 is 9. We don't need any more x's. We already have the x. So that would be our final answer to get that 9x to the first. And if you had extra time on a test or quiz, you can distribute this, multiply it by those 3 terms, and you'll end up with the original problem. Cool? So let's try one more together, and then we're going to be done. Well, then you're going to try one. So we're going to try the second one together. Let's look at the numbers first. 2, 6, and 12. What do they all have in common? A 2. Now, do all of these have a b? Yeah, they all have at least b to the first power. So now we're just filling in some blanks. I have 2b, I need 2b to the third. So what is it missing? It's missing b squared. It's missing 2 b's. Well, I shouldn't say 2 b's. It's missing b to the second power. So 2b times b squared gives us 2b to the third. I have 2b. I need 6b to the second power. So 2 times 3 would give us the 6. b times b would give us the b squared. And the last one, 2 times what would give us negative 12? Well, that's negative 6. I have a b. I need a b. So that's all handled. Again, you could distribute this. 2b times b squared is 2b to the third. 2b times 3b would be 6b squared. Then 2b times negative 6 would be negative 12b. Holy smokes, that's what we started with. Wild. So we'll just do this one together. I know I said I'd have you try it, but what are the only things that this have in common? They both have x to the first. So x times 2x is 2x squared, and x times 1 gives you x. So this would be your final answer. There we go. We multiplied a polynomial by a monomial today.